Imagine a world where the sky might look a little different than what you see today, where the oceans are so deep they stretch beyond your imagination, where gravity pulls you twice as hard as it does while you sit in that chair. Imagine a place that at first glance through a telescope looks so much like Earth 2.0 that we dare to call it Earth 2.0. A world that could have oceans, continents, maybe even life looking back at us. That world exists. Its name is Kepler-22b. Since its discovery by NASA, Kepler-22b has become a symbol of hope and curiosity. It is one of the first planets we have found orbiting a star similar to our Sun in the so-called habitable zone, a place where water could exist, where life might find a chance, and where humans dream of one day setting foot. But there is a problem, a gigantic problem, the kind of problem that newspapers rarely mention. The problem is distance. The distance between Earth and Kepler-22b is so massive that it is almost impossible for our minds to understand. If you climbed into the fastest vehicle we have today, you wouldn't live to see even 1% of the journey. Your children, your grandchildren, even your distant descendants would be long gone before the ship reached its destination. Yet, we still ask, how long would it really take to reach this new Earth? So, why Kepler-22b? What makes this planet so special? Kepler-22b orbits a star similar to our Sun, located in the constellation Cygnus, also known as the Swan. It is the first planet confirmed by the Kepler telescope to orbit in the habitable zone of a Sun-like star. The habitable zone, sometimes called the Goldilocks zone, is the area around a star where it is not too hot for water to evaporate, nor too cold for water to freeze. It is the perfect range for life as we know it. Kepler-22b is about 2.4 times the size of Earth, making it a super-Earth. This could mean massive continents and mountains, or perhaps a world covered entirely by deep oceans. It could even be a mini Neptune, a planet with a rocky core wrapped in thick, crushing gases. We simply do not know. Yet the possibility of a temperate world with water and a stable star is enough to ignite our imagination. If life exists there, it could have had billions of years to evolve. If oceans exist, what kinds of creatures swim in their depths? The reward of discovering such a world is enormous, but the cost, measured in distance, is staggering. Kepler-22b is roughly 600 light-years away. That means the light we see today left the planet about 6 centuries ago. When the light we detect was leaving Kepler-22b, Europe was ending the Middle Ages, and Columbus was preparing to sail to the Americas. 600 light-years. That sounds like a small number, like 600 kilometers you might drive to visit a relative. But in space, a light-year is a measure of distance, not time. 1 light-year is the distance light travels in a vacuum in 1 year, about 300,000 kilometers per second. In other words, the light from Kepler-22b has traveled roughly 5.6 quadrillion kilometers to reach us. Numbers like this are so big our human brains cannot really picture them. The distance is an abyss, a vast void that separates us from even the closest chance to touch another world like our own. Let's imagine we want to reach Kepler-22b today. What could we use? The fastest object ever built by humans is the Parker Solar Probe, which reaches nearly 700,000 kilometers per hour. But it only reaches this speed by falling toward the Sun. If we want to leave the solar system, we need something like Voyager 1, which is traveling at about 61,000 kilometers per hour. Even at that speed, it would take 10 to 11 million years to reach Kepler-22b. To put that into perspective, 10 million years ago, humans did not even exist. Our ancestors were small primates climbing trees in Africa. Chemical rockets, even the most powerful ones today, make this journey completely impossible. Even if we pushed to the limits of current technology, reaching this planet is far beyond our capabilities. So, what if we accept that slow travel is the only option? This is where the idea of a generation ship comes in. A generation ship is essentially a floating city in space, completely self-sustaining. People would live and die aboard it, with their children and grandchildren continuing the journey. Even traveling at 1 or 2% of the speed of light, it could still take 30,000 to 60,000 years to arrive. For the travelers, Earth would become a story, a memory of a home they never truly see. Kepler-22b would become a promise, a destination they may never reach in their lifetime. Life on such a ship would be strange, claustrophobic, and challenging. The problem isn't just building the ship. The problem is maintaining a functioning society over generations. Culture, governance, human emotion, all of it must survive hundreds of human lifetimes. Perhaps the answer is not to accept slowness. Perhaps the answer is to move space itself. This is the idea behind the warp drive, theorized by physicist Miguel Alcubierre. The concept is simple to imagine. Compress space in front of the ship, expand space behind it, and the ship rides this wave, effectively moving faster than light without breaking Einstein's rules. With a warp drive, a journey that would take tens of millions of years could take decades or even years. At 10 times the speed of light, the trip to Kepler-22b could take 60 years. At 100 times, just 6 years. The catch? The energy needed for such travel is unimaginably huge, more than the mass of entire planets. Warp drives remain in the realm of science fiction for now, but the idea shows how human imagination stretches beyond physics itself. So why do we even think about going to Kepler-22b? Why imagine traveling across space at impossible distances? It is because humans are curious, because we are explorers by nature, because there is something in our minds that refuses to accept limits. Kepler-22b may never be within reach, but imagining the journey teaches us about the universe, about physics, about the fragility and audacity of life. It reminds us that we are small, yes, but capable of dreaming big. Even if the journey is impossible today or centuries from now, the questions we ask matter. They push science forward. They push imagination forward. With today's technology, a trip to Kepler-22b is impossible. With tomorrow's ideas, it might take generations. And with the technology of dreams, it could take a lifetime. Kepler-22b sits 600 light-years away, a reminder of two truths, the vastness of the universe and the endless curiosity of humanity. So the real question is this: if a ship were ready tomorrow, would you go? Would you leave Earth never to see it again, to travel through the abyss in search of another home? The universe does not care about our plans, but our imagination, that can take us further than the fastest rocket, the largest generation ship, or even a warp drive could. Kepler-22b awaits, silent and distant, and for now, we can only wonder.